We just have to evaluate the following using this graph. Alright, well, remember again from the beginning of the year what we've done in the past, what value always represents the inside, x or y? X. Okay, x is always on the inside. So again, all you have to do is go to -3 on the x, go up to your graph. What's the y value there? What is it?
6.
5. Do the same thing for f of 7. We know the number inside the parentheses is always x. So go to our x is 7. 1, 2, 3, 4, 5, 6, 7. Go up to your graph. What's the y value there? 6. Same thing with c. Go to where x is 3. Go up to your graph. What do you notice about there? It's open. Can we use that y value? Oh, it's open, meaning the graph's starting at that point, but that point's not included. So you kind of just have to skip it, go up to that closed dot. What's the y value there? 4. So your answer has to be 4. And that happens when you have that open dot. You can't use that open dot. Jump up. The y value there is 4. Which statement did you use, the left or the right, to evaluate this one? What? Do we use the left one or the right one? Right. Why? It has a closed circle. Questions over there. If it has a closed circle, just go to the next one, and then that will be your answer. You can't ever use closed circles as your answer because that's technically not there. It's open. There's nothing there. It's an open spot. Okay? Gotta go to the one that's filled in. Okay? Questions? Go ahead and try to. Give me a minute. Try to on your own. We'll go over it. The x value inside the parentheses. Take the y value. Open. Go to the one that is closed. For f of -4, what did we get? You go to -4 on your x, what's your y value? If you notice, if you try to go up, is there anything? You ever run into a graph? Nope. So then, here's a graph, so we have to go down. What's the y value there? -2. So you also have to pay attention to that. We're in the habit of going up to your graph. Well, there's nothing to go up to. You never cross anything when you go up. So then you have to go to the nearest line, which you're going to go down to -2. F of -3, if you go to -3, which graph are you going to go to? The one, are you going to go up or are you going to go down? Why are you going down? Yeah. Good. If you go up, that's an open circle. We can't use open circles. So you have to go to the graph that has the closed circle. So f of -3 equals what? 0. Oh, go to where x is 0. Well, there's a close point. There's an open point. Which value are you going to use? Open or close? Close, and the y value at the close point is 0. And then last one, f of 5. Go to where x is 5. Go to your graph. What's the y value there? Questions over that? Yes.
Since it has an arrow, that doesn't mean necessarily anything.
No. That you would only arrows are important for domain and graphing. But if we're just evaluating these values, it does not matter if there's arrows.
Alright.
What matters when evaluating is open and close points. Questions? Other questions? This is a question. Right? We're going to evaluate given the actual equation. Okay? We're going to evaluate f of negative 10. Well, it's really important to look at these domain values here. That's going to tell you which equation to plug these values in. Based off negative 10 in those domains, are you going to plug it into the top equation or the bottom equation? At the top. Yeah, good. Your domain is saying we can plug in any x value that's smaller than 0 into the top equation. Is negative 10 smaller than 0? Yep. We're going to plug it into the top equation. What do we get when we plug in negative 10?
30.
Which one are you going to plug 1 into? Top or bottom?
Bottom.
Why? It's more than 0. The bottom one's saying we can plug in any x value that's bigger than 0. Okay, well, 1 is bigger than 0, so we're going to plug it into the bottom equation. And what do we get when we plug 1 in? Leave it as a fraction. Improper fraction. What do we get? A handy dandy tool. Yep. Put that as an improper fraction. Over 9 over 2. 4.5. This next one's really tricky. We have f of 0. Which one are we going to plug it into, the top or the bottom? Why the top? God, it has the line underneath. They both have 0, but this one, the bottom one, 0 is not included because there's no line underneath. Can't use it. Has a line underneath, the 0 is included. We're going to use the top one. Very good. What do we end up getting? And then which equation did he use to evaluate f of 0? Just like we said, he used negative 2x plus 10. Why did we choose it? 0 was included. Included. Line. Underneath. And default. Sorry, I abbreviated default to IN. Make sense? Hi. Yes. Yep. If you were to graph this piecewise function, would each part of the graph have segment or rays? It says starting at 0, you're going on forever in one direction. Here you're starting at 0 and you're going on forever in another direction. Okay? One defined. When we're evaluating, it's really important, like with this 0, you can only use the top equation because it's included. When you're graphing, it's super important to plug those values into both, even if it's not included. Because on your graph, you'll indicate that it's not included by putting an open point. So don't think it's not included, I can't graph that point. You still need to, you just didn't show that it's not included by putting an open point. You just don't do it when you're evaluating. That's what you don't have.